Hi guys, in this video we're going to be looking at rearranging formulae, and just so that we remember this, as we all know that once we see an equal sign, whatever we do to one side of an inequality we have to do to everything. So whatever we do to one side of an equal sign we have to do to the other side. So let's just talk a bit of jargon. The subject of the formula A is equal to 2 pi RH is A, the letter on its own on the left hand side. So if we're asked to make something the subject, that means we want that to be equal to something else. So let's have a look at this example. It says write I in terms of T, M, H and G. So write I in terms of, that means we want I to be equal to something at the end of this. We want I is equal to an answer. So the first method we're going to use here is what's called the storybook method, and you can only do this if there is only one other letter. So what I mean here is you can see there's only one I in this whole expression, or this whole equation I should say. If there's more than one I, we cannot use the storybook method. So the storybook method pretty much goes like this. You start with the letter that you want to be. So I am at I. The next thing that happens to me is I get divided by MGH. I am then square rooted. And the last thing that happens to me is I am multiplied by 2 pi. Once I get to the last thing, you can see here, I'm multiplied by 2 pi. I do the opposite to get rid of it. So that means I have to divide by 2 pi, but I have to do it on both sides. So that means on the left-hand side now, I've got t divided by 2 pi. And I just rewrite everything else. So I've got square root of I over mgh. Now don't try to do too much in one go. I then start my story again. I'm at I get divided by mgh. I am then square rooted. What is the last thing that happened to me? I was square rooted. What's the opposite of square rooting something? I have to square it. So that means I'm going to square everything on the left hand side and square everything on the right hand side. That means I'm going to get t squared on the top. I'm going to get 2 pi all squared on the bottom is equal to, and I've got I over mgh. I start the story again. I'm at I get divided by mgh. What's the last thing that happened to me? I was divided by mgh. Therefore, in order to do division by mgh, I need to multiply both sides by mgh. So I now have mgh by t squared over 2 pi all squared is equal to I, and I'm now finished. I have I is equal to, if you want to, you can change it around and say I is equal to mgh t squared over 2 pi all squared. You could also state, if you wanted, guys, you could say this is mgh t squared over 2 squared, which is 4 pi squared. So all I've done here is multiply or square out this bracket. Okay, so 2 squared will give me the 4 pi squared, will give me the pi squared. As far as I'm concerned, this is fully acceptable. Right, let's have a look at the second technique, and you can see here what we have been asked is to express A in terms of B and X. So we want A is equal to here. That's what it's asking us to do, is A is equal to. Okay, and hopefully you can see that there's two A's. You've got an A here and an A here, which now means that the storybook method that I used on the first slide there will not work. This is what we call the factorization method. Okay, so I'm just going to write it out. We'll see what we're going to do here. So we've got x is equal to A plus B over A minus B. Right, my first issue here is the fact I have this fraction. So I want to try and get this away and up to here. So I'm going to multiply both sides by A minus B. If I do that, I end up with x, A minus B, is equal to A plus B on the right hand side. Okay, the next thing I'm going to do is I'm going to multiply out this bracket here. Okay, and that then will give me A by x minus bx is equal to A plus B. I want to try and get A on both sides. You can see I have A here on the left hand side and I have A here on the right hand side. What I want is I want them both on one side. So what I'm going to do is I'm going to take this one across to the left. And I'm going to take this one across to the right because I don't want anything that doesn't have an a on this side. So if I do that, I'm going to get ax minus a is equal to b plus bx. Now I could have taken all of the a's to the right hand side and thrown everything else onto the left hand side. I'll do that afterwards and show you what happens. Now that I'm here, I've got ax minus a is equal to b plus bx, and I want to get a is equal to. They're right next to each other, they're all on the same side here, and hopefully you can see that I can actually factorise. I can take the a out. So there's an a here and an a here, so the a comes out, and I'm going to get x minus 1 is equal to b plus bx. Okay, just to show you that a by x gives me the ax, a times negative 1 gives me minus a. Now you can see I've got a multiplied by this bracket, x minus 1, and I want to get a on its own. So I'm going to divide both sides by x minus 1, and I'm going to end up with a is equal to b plus bx over x minus 1, and I'm now done. I did say you could have gone another way, and sometimes you will go or you won't get the answer that you're expecting in the back of the book or in the solutions that you have. So I'm just going to show you why that's the case. So if we go back up to this stage here, and we decided to take this a across and we took everything else that wasn't an a across to this side, I'm going to go the other way and I'm going to move the a's to the right hand side. So I'm just going to rewrite it. It's going to come over here, okay, and say that what we have is ax minus bx is equal to a plus b. And this time I'm going to take the a's to the right. So this is going to head over to here, and this is going to head over to there. If we do that, we end up on the left hand side, we end up with minus bx minus b is equal to a minus ax. Now again, hopefully you can see that I should be able to factorise this, so I'm going to do that. I'm going to get a, I'm going to get 1 minus x, and I have minus bx minus b. And don't forget your equals sign. Like before, I have a multiplied by this bracket, so I can take that underneath. So I'm going to end up with a is equal to minus bx minus b all over 1 minus x. Now, this is perfectly correct, as is this. They're exactly the same expression, but written in a different way. If I multiply every single term in this fraction here by negative 1, you'll see that this becomes a positive bx, this becomes a positive b, this becomes a minus 1, which is here, and this becomes a positive x. So what I'm essentially doing is multiplying by minus 1 over minus 1, which doesn't change the fraction because minus 1 over minus 1 is just 1. If I do that, what will happen is it will go to this fraction here.